to achieve. So basically that will switch over to Matt's presentation to talk to you about the outreach and communications. So we need the steering committee to be aware of that, to weigh in on it, of whether or not you think it's complete and the point of contact is appropriate, et cetera. The second question we'll be asking you obviously is about the messaging itself, how we're presenting the materials from our research as it relates to the audiences. And again, Matt can frame that as either a general audience or policymakers, meaning congressional outreach. And then the third question we'll have that we probably won't really resolve, but we will kind of tee up, is the question of possibilities of next steps or expansions or further developments of the research that you'll be presented. The attachments that you have in your email are simply informational and/or as a resource should you need them and not be able to access the WebEx. So if you're not able to, if you're on travel or something, then you can at least follow along on the slides. So I'm going to immediately make the introductions and turn it over to Jessica, unless there's any other quick questions that anyone has to bring up. Okay, so on your slide on the WebEx, or the first slide in your PDF, the first thing you see is the slide of the AppLCC staff. And so since the steering committee met in person last, I guess, in September, we were able to hire two professional staff. So Jenny Kryler, that you know from our steering committee previously, and Mary Davis, who some of you have probably worked with quite extensively in the South through her work with the science and the Southern In-Stream Flow Network, and of course with START. So both of them have joined our team as of January. Mary is focusing on all of our southern reach, but also the commitment that we've made to working with the Tennessee River Basin Biodiversity Network. And Ginny is working in the north right now, has worked quite extensively with our Pennsylvania field offices and partners, and will start moving into the West Virginia. Today's first speaker is Jessica Rhodes, and Jessica's been with our team for quite a while, but is always the Wizard of Oz behind the curtain and makes all of these maps and things for us. So Jessica will be talking about one part of the interagency agreement research, and Lars will actually talk about the research, but Jessica will be talking about the resource that was generated out of that and how that has become a tool for the LCC community. So Jessica, over to you.
All right. So as Dean mentioned, I'm going to talk to you about the resources that are available through the Ecosystems Benefits and Risks tab on the portal. So this is a clearinghouse for a lot of the ecosystem services information and data throughout the Appalachian region. So this is just a bunch of compiled information for users to access. And so this will help conservation managers making their decisions. It's comprised of 3 different areas. So there's the guide, and this provides key references to the information, and it groups the data. There's also a conservation atlas. So within this, you can get, abbreviated descriptions of what the data are, and you can also access maps that showcase the data, and you can find links to actually access the data on the web. There are also a group of assessments. So the researchers compiled the assessments that they reviewed to find these benefits and risks. So there's a list of those as well. And so the first, I'm going to show you what the guide looks like. I'm going to show you screenshots from each of the categories. And so within the benefits, you can see that there are several groups of data. So There's water and soils, landscape values and census place, harvested species, and forest carbon. So within each of these, if you go to these categories on the portal, you can access information about multiple data layers that fit within these groups. And so the categories are pretty self-explanatory, and there's also a PDF icon up here. You can actually download a PDF of the benefits, so it'll be a summary document of the benefits within the area. There's also the risk category. So this is the risk associated with the benefits that you saw on the previous slide. And these are also organized in the same way within groups. So this category has 5 groups of data. And you'll be able to, if you go further in, you'll see a breakdown of different data layers within these groups. Next, I want to show you an example of information that is available within the guide. So we're going to go into one of the categories, and this forest carbon is within a benefits category. So when you go into a description, you can see that there is a general information here. There's risk factors. So if it's within the benefits, you'll see risk factors associated with that. And you also have a list of references. And this is really nice because it not only tells you the assessments that were used, but it also provides a hyperlink to that document. So if you want to look into that further, you're able to do that really easily and find that information. The next category is the Conservation Atlas. So this is a little different. It provides a brief summary of the data, but it also will provide you maps and you're able to view the data within that. So there are similar categories as to what was available in the guide, and this is an example of the different categories that are comprise the benefits category. So you can see the forest to faucet data layers, there's forest industry, there's carbon mapping. So you can see these are all examples of the data that you can access within this category. There's also a risk category similar to what was in the guide. And once again, these are groups of data. You can see the information, the different data resources that are available within this category. And in addition to those, there's also a human landscape category, and this is not one that we saw in the guide. So this information is needed to help assess the benefits and risks, because the benefits that are derived from the landscape depend not just on what the ecosystem's present, but also on the people present and how they use these. So this was an important category as well. And you can see an example of some of the data layers that are included within this category. So if you're in the data atlas, you can look in one of those categories, and this is an example of one of the risks. So this is the invasive species and forest pathogens group within the risk. And so you'll see that there's a summary here, and so it gives you a little information about that category. And then you also see links, so you see down here in the data atlas, there are 2 categories of their data here. So if you click on one of these forest pathogens, it will take you to a summary page for that data where you have a more specific description of that data layer, and there are thumbnail maps that you can see here of the data. And this was also available on the data summary page. You can also, if you click on these maps, you can also expand it to a larger image if you want to view that a little closer. You can learn more and access the data. Here is the link here. So I'd mentioned that within this guide, you were able to go back and find links to the data. So this will take you to information about the original publisher of the data. And these reference find links, this will take you back to the guide that I showed you first. So that just takes you back to the summary of that data grouping within the AppLCC portal. A nice thing about these data layers now is that we have also moved them into Databasin. So within Databasin, you can you'll be able to download them. So you can preview the data here, and you'll be able to download it. So this is then a screenshot of databasing. So once you get into databasing, you'll see the AppLCC has a gallery here, and we have multiple folders within the gallery. All the ecosystem services data are within this folder here, and you can see that it has 41 items. So if you click on that ecosystem services, it'll pull down a drop-down menu, and you'll be able to view a thumbnail of all the data layers that are included. And from there, you can download, like I showed you in the previous slide, or you can open in a map viewer if you just want to view it through the web. So there's a lot of flexibility that you can do, and we tried to make it really easy for users to access the data. And this is a screenshot of what the Conservation Planning Atlas for the Appalachian LCC will look like. And we expect that to be finalized in a couple weeks. So we're within a gallery right now, but we will have our own Conservation Planning Atlas shortly. And you can see there'll be links to other LCCs, and we'll have multiple galleries then within our own Conservation Planning Atlas. That's just to give you an idea of what is coming. So I've mentioned a little bit about the data and resources that are available, and we want managers to be able to look at our tools, and then the tools can help, and they can feed that information to field users in the field, and then so it's all an interactive piece. So we have managers, users, and all of our tools, and they're all interacting together. And I wanted to show you an example of how that interaction occurs. So first, a user in the field might run the riparian prioritization tool, and you've all heard about that. So here's just an example of what an output from the RPCCR looks like. And you can see that this area here in the red circle, you see the dark blue areas. Those are areas based on parameters that were set in this window to the left that a user specified to try and identify areas that they want riparian corridors to focus on. So this is an area in the upper James in Virginia. So you can see we want to look at this a little closer, but we also want to consider potential energy development within that area and how that could affect our decisions. So this area in the first map on the left, it zooms in a little bit and shows you where we ran the riparian analysis. So this is the same analysis that was run. And if we overlay that, we can see that some of these areas do have a high risk of wind energy development. Then on the right, you can also see these yellow hash marks also indicate these are watersheds that have bad occurrences. So we know that this area could be important for riparian protection. It also has a high risk for wind energy development and has a watershed with a listed bad occurrence. So all of these are adding up as to an area that is likely important. And so you can see I've also overlaid this with the bad occurrences. You can see these large yellow blobs are where bats have been known to occur. And so this is also, you can see that this matches up with the other maps that I just showed you. So we know this area is pretty important. We also then want to look at, okay, we know the ecosystem, we know that there's important species there, we know there's things that we're worried about and concerned about. We want to look and see, with this ecosystem benefits and risks, are there additional concerns, are there additional risks to these species that we've identified? And so I mentioned bats, but so then we wanted to say, okay, are there potential impacts to, their food sources? And so one of the things we looked at just as for this example was invasive species and forest pathogens and how this could potentially affect the bats and resources that they need. And so this is color-coded. You can see this is the same area on this map on the lower left-hand side. And within this one, these dash marks indicate those same hucks with bad occurrences. So we can look and see that this area there's no the really dark blue areas that have a high threat, but if we go over here, this is a slightly different area on the map. It's just underneath that red square. That this area, oops, sorry about that. This area does have a higher risk. So it currently doesn't have the riparian, but this could be an area that's at risk that we also might want to focus on. So we look at all of these information sources and we can combine them together to make a picture of what is needed for the conservation resources. So envision all of these pieces interacting together to help managers and users in the field make decisions on their workload and their priorities. Does anybody have, that was kind of quick, but does anybody have any questions they want to ask real quick before we move on to the next presentation?
Jessica, are you going to go ahead and talk about the online training?
Oh, yes, sorry about that. Yes, so we have, we have all these tools and resources, but we have a lot of users that want to use them, which is great, but so we don't have the resource to go out and teach them in person. So what we've done is we started the development of an online learning platform, and this is a screenshot of an example of some of the courses that we currently have available that we're working on. The riparian prioritization tool, that one is a complete course, and what these courses do is they allow users to walk through a self-paced learning environment, which includes videos and some text that they read, and they also have instructional exercises that they will walk through with the assistance of handouts that will help them learn the technical aspects of using the tool. And we also have assessment quizzes to help users understand and gauge if they have understood the important points and what the tools are intended to do. And a final component of each of these classes and platforms is that we also have a feedback mechanism. So we get feedback from the users on how the tool worked for them, how the class worked for them, and any additional features and resources that they might want additional classes on. So we want to have that feedback loop going so we can make these tools and classes the most useful for our users and provide the most support to the conservation community. And the URL for that is at the bottom of this slide. And that was the last step. And so this is my contact information. If you have any questions, you can contact me about any of the tools, resources, the online learning platform.
Well, thanks, Jessica. Obviously, I hope the steering committee is impressed with your ability to communicate the integration of the tools. I do want to stress the fact that the materials on the ecosystem benefits and risks was developed and assembled through the interagency agreement with the Southern Research Station. And as I say, it's one of the two components for that collaborative research. This is just, again, the resource part of that collaboration. And now we'll switch over and allow Lars to introduce the second part of that funded work, which is more of the in-depth research component of it. So, Jessica, if you want to pass the ball over to Lars, and Lars can set this up. I know he's presented at a couple of our steering committee meetings before, but this is an update in terms of his research. And then after his presentation, we'll stop for a minute to see if there's any clarifying questions. Lars, is that okay?
That sounds great. So let me ask first if everyone can hear me okay.
I'm good.
Yep.
Okay, great. So let me share. And Jessica, do I need to, oh, I see you logging off right now. Okay.
It just finally passed it over, yeah.
Great, great. So I'm going to share my screen. I am hearing a little feedback, so I don't know if anyone has got a microphone on or anything like that. Maybe check that. I'm hearing my own voice.
Is there a way that you guys can mute others just to help that? Does somebody have the control to mute everyone?
Well, at any rate, just to kind of a shout out, anyone want to check their mute button and make sure that it's on. But I'm fine just to move ahead here. I know let me check my clock. We're running about 5 minutes behind, so I'm going to try to move fairly quickly. So Jean's already mentioned what I'm going to talk about here really is what we're calling the phase 2 of this project. Jessica's done a great job introducing a lot of the online content that represents a lot of the deliverables from the first part of the project, the assessment inventory of ecosystem services and environmental threats. And what we've done essentially is kind of identifying what we feel like are some of the greatest needs and information gaps, and moving on with new research to assess ecosystem service sustainability across the Appalachians with regard to various kinds of large-scale landscape stressors or threats. So what I want to really focus in on is the new set of tools we're developing to look at landscape resilience metrics, or develop resilience metrics for assessing ecosystem service sustainability. And this is, like Jean mentioned, is kind of an update from last year's steering committee meeting. So I'll move more quickly through some of these introductory slides and methodological slides in order to have more time to focus on sort of next phase deliverables in the last few slides. So just real quickly, when we're talking about sustainability, we're thinking of the different capacities of different landscapes to provide a variety of kinds of benefits to people, and those capacities vary, of course, with changes in the physical environment, with changes in society, and we're trying to develop tools to better understand the capacities of large landscapes to sustain ecosystem services given these kinds of change. Jessica's already kind of gone over, let's see, I am now the host of this meeting. I'm going to close this. Is that okay to close this out, Matt? Oh,
what do you mean by it?
Oh, sorry, you're probably not seeing what I'm seeing. I'm going to try to, as long as it's not in anybody's way, I'll minimize that. The recorder became visible for me and it blocked some of the slides.
No.
Anyhow, as long as everyone's fine, I'll just keep moving ahead. So Jessica's shown us the availability of a lot of these data sets we put together, representing the multitude of different landscape scale drivers of change, like urbanization, energy development, likelihoods, climate change. Over on the left, I'm just representing some of this quickly. We know that these are all impacting a variety of important ecosystem services or benefits across the LCC, like the ability of forests to produce clean water sustainably, forest carbon storage for climate change mitigation, the recreational use of outdoor spaces like bird watching and hunting and so on. These categories are really 3 categories that kind of rose to the top of the list in terms of what we saw as a recurring importance to multiple stakeholders across the region. And I'm going to focus in as an example of the kind of tools we're developing on forest carbon today. So as I said, we know that these, let's see if I can.
Oh. I'm just seeing the first title slide. Is everybody?
Yeah, I'm actually realizing now I'm on the 3rd slide, but I'm not able to forward anymore. Is there an issue with the slides here? Are folks seeing the 3rd slide, which has 6 maps and some photographs on it?
We've been stuck on the title slide.
I'm seeing the 6th slide, so it must be a buffering thing of the servers. Now I'm back to the 2nd slide.
I flipped back to the 2nd slide and then forward to the slide I'm on to make sure folks are seeing it.
I'm seeing the changes that you're making in real time.
Okay. Well, it sounds like some people may be having some issues. If you're stuck on the 1st slide and you're not seeing the 6 maps right now, you may want to open up the PDF that Matt sent out yesterday And I am going to just mention when I change slides so that those folks can follow along. So in the interest of time, I'll just keep moving. Does that sound good?
That'll work.
Yeah.
Okay. Okay, so I changed slides to the next one. You should see a landscape resilience title here. And landscape resilience really encapsulates a lot of what we want to try and monitor with the tools we're developing, namely the impacts of various kinds of land use change and climate change and other stressors on the capacity of large landscapes to provide multiple benefits. And so the tools that we've really been developing to try to actually monitor and assess resilience in this sense really focus in on the importance of monitoring disturbance and succession of the vegetation at large scales, because that's where you really see the impacts of, for example, forest clearing, drought impacts, et cetera. All of the different kinds of impact factors are going to be observable if we can look in pretty fine detail at what's happening to the vegetation. So the data set we're relying on it comes from the MODIS satellite, and without getting, again, into too much methods detail here, I'm going to quickly show some illustrations of how we're developing these data sets to eventually arrive at vulnerability assessments for the ecosystem services that are really the focus of the work. So on the upper left here, you can see, well, on both graphs, you can see two different ways of representing the MODIS vegetation greenness data. It's really a surrogate for vegetation productivity at the scale of these 250-meter MODIS pixels. And the advantage of the MODIS data is really the temporal resolution. You can see that we get multiple readings within a year. So we can see high in DVI during the summer, low during the winter, in the case of this one pixel that I'm showing here. We can also see over time land use change impacts. We can see a reduction in productivity and then successional change leading to recovery in the later years. So these are the raw data that we're starting with. And the reason we make these circular plots below is to be able to calculate some basic statistics on these annual data. These plots wrap the years over on top of each other. So we're looking at an annual cycle, and for every year, we calculate the 6 variables on the right here and use those to cluster the data so all the pixels can be mapped in terms of their class. More similar pixels that behave where the vegetation is behaving similar to each other get grouped together. And so within a year, we can then map the different kinds of phenological behavior of the vegetation over the annual cycle. And what that really allows us to do is to get those annual summaries and then stack those maps up. We're looking at 15 years of data here since 2000 to the present, and look at the change over time. When we see large-scale disturbances, they cause a change in the classification of the vegetation. And when we see recovery, that causes a change. So when we group on the left-hand side, I'm now at the slide, we should be seeing on the left-hand side a map with some white hexagons superimposed over these phenoclasses. So those just group landscapes at an arbitrary landscape scale, and we're actually doing these analyses at multiple spatial scales. We can see differences when we change scales, but that just groups several hundred of these pixels, and then we're able to calculate some more statistics from information theory, actually, like the Shannon diversity, which is familiar to ecologists, based on the transitions among different phenoclass types. So what I really just said is we're observing the landscape dynamics and the heterogeneity through space in those dynamics over time. So on the right-hand side, the kind of orange map there on the same slide, looks at one of these metrics. This is just the Shannon diversity of the different kinds of transitions that we see in the vegetation. But there are a whole family of these metrics from information theory, like the mutual information, the conditional entropy. I don't want to spend time here, again, too much detail, but I do want to show you some of these maps of these new landscape resilience metrics for the LCC because they show very interesting pattern. And the point of this next slide, I just changed to the landscape correlates of mutual information slide. That's the title at the top. The point here is just to show that these MODIS satellite imagery derived metrics at high spatial resolution are really encapsulating change over time in the ecosystems that they represent and across space. And they're strongly related to a lot of the more traditional spatial variables that we're used to seeing, like measures of forest fragmentation, measures of, for example, drought variability, but other kinds of climate variability, land cover diversity. So they really are integrating multiple kinds of impacts on vegetation from multiple different sources and summarizing them in terms of the organization and complexity of the landscape dynamics. So again, there's a whole variety of these metrics, and we don't expect any one of them boils down to something called resilience, but that collectively they're able to address multiple kinds of questions that we have about the actual resources that we care about, and they are dynamic over time. So they're not just spatial models. We're looking at them as maps here. I just switched to the conditional entropy slide. We're looking at them as maps, but they're really summarizing the dynamics over time as well as across space. So lastly, I just want to show an example of how we're then utilizing this new family of resilience metrics to examine a particular resource or particular service. So I mentioned carbon storage would be the example I give. Let me just highlight on the lower right-hand side. So this slide shows two green-colored LCC maps on the right-hand side for carbon density. On the lower map, we're looking at the Forest Service's FIA, Forest Inventory and Analysis, estimates for forest carbon density. So these are really tied to the tens of thousands of field plots where carbon storage, among other metrics, get measured directly from the tree censuses that happen on those plots. And so that map is really tied to those field data. Now on the top, we're looking at our MODIS-derived metrics model or predictions for the FIA carbon density estimates. So what you should be seeing is essentially the maps are incredibly similar because with a few of our MODIS metrics, we're able to predict the vast majority of the variability in estimated carbon density across the LCC. So this itself is a nice new product. The point of our ability to move the FIA estimates into the MODIS system isn't just to replicate it. What it is to move it into our dynamic framework over time. And so this next slide gives an indication of why that's important. So I just moved to the slide that's titled Sustainability, Expected Shifts Given the Observed Dynamics. So we're looking at the past 15 years of data, but the data are being collected continuously over time as we move forward into new years of data. And what we're doing across that 15-year time window is looking at all the dynamics that we observe, and these are all basically just based on some fancy matrix algebra. But if you're familiar, for example, with matrix models and population dynamics, population ecology, what you know is that those matrices allow you to project the observed dynamics over the long term to see what you would see if you allow those same dynamics to play out over the long term. So, for example, on the left-hand side, what we're looking at is areas that, given the kinds of dynamics we've already observed over the past 15 years, these are places in darker red that show if we continue to observe those kinds of dynamics, we expect long-term shifts in the kinds of dynamics that we're seeing from current states into new states. So some places show long-term shifts, and other places, even though there is dynamic land use and land cover change going on, over the long haul, those small-scale local changes don't add up to long-term change. It's a dynamic equilibrium. So on the right-hand side, in the green and yellow and pink map, those expected long-term shifts are translated into NDVI changes. So those are vegetation greenness changes. So in the darker green and yellow, we're seeing long-term shift expected towards higher NDVI classes. In the pink and white, we're showing expected shifts towards reduced NDVI classes, and those would correspond to expected long-term changes in the capacity of those landscapes to store carbon, for example. So what I'm not showing here is the full dynamic carbon model, which is ultimately where we're headed with this as a deliverable. Now, all the landscape resilience metrics themselves, and these maps that I'm showing here, for example, these all represent project deliverables, and we expect that they're very useful, not just for one modeling exercise like carbon density, but for a multitude of uses. And we're calculating the metrics at the national scale. So, for example, other LCCs that are interested in pursuing some of this kind of work will have the same data available potentially in the future, right? So, so in many ways, this is our first kind of test case, but the carbon density dynamic model, ultimately where that goes is it shows expected shifts in the sustainability of the resource, right? So places where we expect the capacity of the landscape to be reduced as a result of the different kinds of drivers that we're observing, or enhanced, conversely. So in terms of expected uses, I've now shifted to the final slide that's just a text slide. We're developing tools to monitor and interpret landscape change, and those result in spatial tools, for example, for planning with respect to vulnerability and resilience of various different kinds of resources. For example, now within a planning context, among places that have already been prioritized for conservation activity, we think that the new metrics can really help to identify opportunities for different kinds of ecosystem management approaches that may be more or less appropriate given the landscape dynamic context, so restoration activities, for example. And one thing we're certainly seeing is that the variety of metrics we're developing are useful for modeling resources of concern, but we're also starting to see that they could be potentially very useful, for example, for distribution modeling for individual species even. And there's really just a variety of applications that we see moving forward. So in terms of project deliverables, we definitely intend to make the full library of raster spatial data available along with the resilience / vulnerability spatial models for targeted resources like carbon storage that we're working on now, but we definitely are also moving on to some of the other important ecosystem service models that I mentioned early on with regard to water and outdoor recreational use. And then over the long haul, where we're really trying to push this is into a web tool context that we're calling LandDat. So a new set of tools, that's landscape dynamics analysis tools that are made public with the full data library, but also with case studies and narrative descriptions that really describe what other people will be able to do with the new tools we're developing, making it all available for download and et cetera. So what we really hope is that what we're doing isn't just our own sort of a few vulnerability models that will be useful in themselves, but limited with regard to what could be done with the new resilience metrics, but making those more widely available so that other people, maybe other LCCs or other within the LCC conservation partners who have different questions and see maybe the utility of what we're offering for their own work or their own questions, that those will, the tools are made available widely to partners and stakeholders. So I'm going to leave it at that, and let me see. I think we're still roughly running about 5 minutes late, but that wraps it up for me, so I'll just leave it at that for now. Thanks.
All right, we're going to transition to our last presentations. We are having some technical difficulties. The Cisco WebEx server is experiencing difficulties. Maybe there's too many WebExes going on at one time this morning. So Todd and Brian, who are to give the presentation, can't log on to the webinar, but they are on the call, right? Todd and Brian, are you guys there?
Todd is here.
Brian is here.
All right, so we have the PDFs I gave, and what I'll do, I'll share my screen for the PDFs, and if Todd and Brian, you can kind of just navigate me through what slides you're on. I will share my screen, and we'll use the PDFs I'm showing up.
Will do. Will do. Thanks, Matt. Thanks for accommodating this. I'm sorry for the difficulties.
No worries.
So you got the first slide up there. It says environmental flow analysis for the Marcellus Shale.
I do, and
okay.
The introduction slide as well.
That's okay. Great. So I'm Todd Balter. I'm a professor at Cornell University, and Brian Buchanan has been a postdoctoral researcher working on this. And so this whole issue of environmental flows is sort of a global issue. There's dams going up all over Vietnam and South America, and so a lot of people are looking at this. And it hasn't escaped North America either. Even as we're trying to remove dams, there's a whole bunch of water withdrawals that have to happen in places where we're doing gas, well, any kind of natural gas or oil extraction using sort of contemporary methods. And so if we go to the next slide, should say Introduction to Marcellus Shale Region. Okay, so the region we're looking at is really interesting because it drains to the Gulf of Mexico and also to the Atlantic seaboard in a couple different places, and it has it's incredibly important as a drinking water supply. It's also really important ecologically because there's oh, am I still on?
I'm here. I can hear you.
Okay.
Yeah,
I am here.
Okay, I'm getting like some other weird stuff happening here. Anyway, I'll keep going. From a biodiversity standpoint, it's also super important. For species, lots of pristine areas. If we go to the next, and it covers a huge part of the eastern United States as well. So if we go to the third slide, and I'm sorry these aren't numbered, that to access things like the Marcellus Shale, which is a very shallow or it's not a very deep strata of geology to withdraw natural gas from, they do this horizontal drilling, kind of cool in and of itself, but it requires them to do hydrofracking, which means a lot of water down into this geological strata to kind of open up these cracks. And this is what the main concern is for us, is that they're withdrawing water from the local streams and rivers to pump down into these wells. This is also what geologists call dry strata, so that water mostly stays down there. You don't get very much of it back out. Okay, you can see in this lower left-hand figure here, sort of the density of wells that are being established here. So you can see there's kind of a hot kind of thread right through the middle of the formation. And if you look over here on the bottom right-hand side, you can see that stream. You can see both banks in this photograph, and there's 5 or 6 pretty big hoses withdrawing from here. So there's a potential to withdraw a lot of water from some very small sensitive streams in this area. And if we go to slide 4, which is a map showing just sort of the density of wells, or showing all the places where there are either active wells or potential wells, or projected wells. You can see this is kind of a huge swath of activity throughout this region. And so each one of these dots is going to have to involve, potentially millions of gallons of water to actually activate that well. So this is what kind of motivates the concern here. And if we go to the next slide now, Matt.
Yep.
So our goals really were to look and see kind of what were the potential ecological impacts from this activity. This is kind of a basic research question. And then can we actually translate that information into some sort of management guidelines that would allow this, potentially necessary activity to go forward with sort of minimizing the ecological impact. Those are things. So if we go to the sixth slide here, I just want to point out that this is not a local problem, even though we're focusing on the Marcellus. This map is sort of showing overdraft or places where there's potential for withdrawals to have huge impacts in general. And this is primarily looking at groundwater, but so the Marcellus region shows up as kind of a non-huge impact. It's still 0.25% change. It's still pretty big. But the point is simply that what we're doing here in the Marcellus region has implications all over the United States. Okay, so if we go to the seventh slide now, we should have three maps here. And this is just kind of show you, we chose to do a very data-driven approach to this. Use whatever data are available out there and draw our conclusions based on empirical evidence rather than trying to do simulation modeling and stuff. So you can see here, in this region, one of the things, there are a lot of USGS gauges. Okay, and you see on the left side, this shows you all the gauges that are monitoring stream flows for watersheds where there's been substantial alteration done to the system. The middle one is showing you what we're kind of calling our pristine or natural gauges. So there's about almost 200 of those. And then we had to wade through about 10,000 or over 10,000 sites where there were ecological observations that we could kind of relate our flow alterations to see what were the flow alterations doing to the ecology. So it was a very data-intensive process. We go now to the eighth slide. This will kind of show you what we actually did, to kind of figure out how would the potential pumping of water out of these streams impact the ecology. And so what we did is we looked at a whole bunch of potential ecological responses based on those 10,000 sites, over 10,000 sites that we looked at, and we can choose sort of like indices that we would use to measure ecological response. And so over here, Brian actually listed 6. I think we had more than this, but there was at least 6 different things, like species richness, how many species are present, total abundance, all these different things could be different ways to measure ecological response. And then percent flow alteration, that sounds nice, but what does that actually mean? And we actually, I think we took our marching orders a little bit from the Nature Conservancy. We looked at 18 different flow metrics. So things like minimum summer flow or median February flow, or all these different ways of trying to figure out how has this particular metric changed as the watershed has been altered and the flow has been altered. And then we, of course, related that back to these ecological metrics. Okay, so you can see that you have 18 flow metrics and at least 6 or 8 different ecological metrics. So you have a whole bunch of different ways of trying to evaluate this system here. And so what we ultimately wanted to do is go back and say, okay, if we know what this ecological response is going to be to the changes in flow, can we go back then and do some simulation modeling? So this left-hand figure is kind of showing you how we kind of layered in some different things that we knew about where there was likely to be gas well drilling, where different ecological metrics how they were going to be distributed throughout the region, and how sensitive the bottom sort of like map there, it's buried, is sort of how sensitive those metrics were to changes in flow alterations. We kind of combine those all together with our knowledge of how changes in flow with influence technology maps that of sort of what the most sensitive areas were throughout the region.
Matt, you want to advance the slide?
Okay, I wasn't sure if you moved on or not.
Oh, sorry. So what does this mean for water withdrawal? This is what I'm on now. Gotcha. Okay, we're there?
Yep.
Okay. So we kind of take all this information on the left-hand side that we've gotten, we can kind of garner from the web. We got this middle graph is sort of stuff, relationships we developed by looking at the available data, and we can put those things together to come up with maps of sort of sensitivity for any species or ecological metric that we wanted to look at. And so, you know, I think we actually worked all the way through this whole process for maybe a half a dozen or a dozen different ecological metrics or individual species even. And so I'm going to let Brian take it from here and kind of just show you some examples of the types of things we actually found out. So Brian, you want to take over on slide 10, which has a billion little graphs.
Yes, hello all, this is Brian. So we're on to the findings here, and we're not expecting you to digest all of these little graphs. It's more just to show you that we looked at a lot of different combinations of flow alteration versus the ecological response to those alterations. And we don't really have time to go over all of them, of course. So we're just going to be focusing on the two that are kind of highlighted there in those little red boxes. And they deal with species richness. So we'll go ahead on to slide 11. And that should show you a bit more detail about the species richness relationships that we found. And so basically what we're looking at here is how the species richness declines so significantly with reductions in the summer median flow and the annual runoff. And those both are on the x-axis. And so the data points here are sized in proportion to the watershed area to try to see if watershed size was sort of confounding some of our relationships, and we didn't really see that, but we won't get into all that detail here. But as you'll notice, there's a fair amount of scatter in the data. That's fairly typical for flow ecology curves. And to help us evaluate, you know, the sort of patterns.
Matt, you want to advance it down to the two?
Okay, yeah, Brian, if you can just let me know when you're changing slides.
No, go back up, Matt.
Yeah.
Yeah,
okay.
so we should be on slide 11, which is a zoom in of those two species richness flow ecology curves.
Yep,
and
there.
So hopefully to catch you up here, and you know, as I was saying, there's a bit of scatter in this sort of flow ecology data, which is to be expected, and that's why people typically apply something called quantile regression, and that just allows you to describe how the best possible biological status changes across the varying degrees of flow alteration that we see as we go from, you know, the far left-hand side of the x-axis to the far right-hand side of the x-axis. So for our study, what we did is we chose to look at the 98th quantile, and that will describe our upper bound response. And if we look at the 0% alteration line, which is that blue line in the left graph, we can basically interpret that as saying there's a 90% probability that under 0% or, well, 0 alteration, the best species richness would be around 22 species. But if we see a 35% reduction in the summer flow, which is that red line, which connects with the x-axis at around 35, then our best case scenario is that we'll only have about 16 species. So the basic idea here is that, you know, less summer flow, or, you know, if we're looking at the graph on the right, less annual runoff means significantly fewer fish species. And we found that that general trend applied to a number of ecological metrics, as we saw in the previous slide, and also different flow metrics as well. So we saw these sorts of general wedge-shaped distributions that decline across many flow ecology metrics. Now, in order to be able to use these flow ecology relationships effectively for our purposes in this study, we need to understand what the likely range of flow alteration might be due to withdrawal associated specifically with hydraulic fracturing. And so, we're wondering, are we going to see a flow alteration in for this blue shaded region?
Okay, so we're on slide 12 now.
Oh, I'm sorry. Yep, we're on slide 12. Forgetting about that. Sorry, guys. So in order to be able to understand this effectively, like I said, it would be helpful if we could get an idea of what the magnitude of the flow alteration is going to be. And, we're not sure. Is it going to fall in the 0 to sort of 10% range, which is, described as this blue shaded region, or is it going to be greater and more significant, like as in this sort of yellow shaded region? And so that's where our pumping scenarios kind of came into play. And this slide is to kind of give you an idea of the various combinations of pumping scenarios that we implemented.
Slide 13.
Slide 13. Thank you, Todd.
Pumping scenarios plus flow standards.
Yep. Not used to saying that. Yeah, sorry, guys. We're on slide 13. And so this slide is just to show you, as I said, essentially the number of different pumping scenarios in combination with different flow standards that we enforce when doing these withdrawal scenarios. And so the table on the left is just showing you a list of our 6 flow standards that we implemented. And we highlighted for you in that red box the C&C flow standards, which are probably the more complex of the bunch, because they vary according to seasons. And there's also some withdrawal caps, and those are all a function of exceedance flows, which is these pass-by flows here. If you look, it says 250, 270, and those all refer to exceedance probabilities. And so what the graph on the right represents is we have date along the x-axis and we have discharge along y. And so the black line is essentially the natural flow with no withdrawal whatsoever. The red line, which is the lowest, like if you see it, it appears in the bottom right, that essentially represents withdrawal without any sort of pass-by flow standard enforced. And then all the various other colors all represent the different kinds, of pass-by flows that we implemented. And so if we go to slide 14.
Actually, Brian, before you go on,
yeah.
Is this graph on the right showing because you had like low, medium, and high pumping scenarios. Is this a
right.
high pumping scenario?
This is the median pumping scenario.
Medium, okay.
Yeah. So yes, and it would look different depending on which pumping scenario. We just chose to pick one to show here to translate it, because I think a lot of people are used to seeing hydrographs. That's essentially what this is, just with different levels of flow extraction and flow protection input. And so
we're looking at about another 5 minutes or so before the discussion.
Okay.
If you go to slide 14, we can use our flow ecology relationships, and we can translate the pumping scenarios and the flow standards into sort of ecological ramifications. And that's what we're trying to show here in the series of graphs on the bottom right, where we have pumping rates are increasing. If we're looking at the graph on the right, pumping rates are increasing from left to right. So we've got low intensity increasing to high intensity. And then we've got stream size is increasing from top to bottom. So small headwaters increasing to medium tributaries. And the shaded regions basically represent these hypothetical biological condition categories. And essentially what that translates to is, as you go from light gray to dark gray, you have more and more ecological degradation. And so these shaded regions were determined using our species-richness flow ecology relationship that we showed previously. And so some of the take-home messages from this graph are essentially that, number one, the ecology in small streams is especially accessible. And you can see that many of the box blocks there in the top row of that figure are shifted pretty far to the right. They're in the bad dark gray territory, essentially. And a second point is that the T&T guidelines, which are highlighted by these little red boxes, are doing a pretty good job of mitigating pumping impacts. And we had a couple of the other standards that did a fairly good job too, but we found that they were a bit more essentially overly restrictive in terms of allowing a reasonable amount of water for human use. And so the T&T seemed to find a better balance between ecological water needs and human water needs. And moving on to slide 15, here we're looking at some of the results of our risk analysis, and essentially what we did here is we incorporated some data from an existing AppLCC funded study looking at gas well development in the Marcellus Shale region and the Appalachian LCC in general. And we incorporated that data here as the probability of gas well development. We combine that with the probability of a particular species presence. So in this case, we're actually looking at a gill. So the probability of the gill nest builders. And these guys are essentially species that have similar flow requirements during nest building, spawning, egg, and larval development. And we combine that with the ecological sensitivity to soil operation to generate this cumulative risk map, which essentially is saying if you're in the red, then it's a high probability that there's going to be nest builders there, there's a high probability of gas well development, and there's a high probability that that particular stream is going to be quite sensitive to flow alteration. And so with that, I'll pass it back to Todd, who will talk to you about the proposal.
Thank you, Brian. And so we could make these kinds of maps for any kind for multiple gills or multiple species if we had the resources to do so. And in fact, that kind of segues now. If we go to slide 16, we're thinking about what maybe the next steps are. And having gone through this, we have some ideas of how to improve what we're doing. But primarily, what we'd like to do is we'd like to develop more of these risk maps for different pumping scenarios, different flow regulations, different types of species or gills that we might be interested in, and then potentially put those out on some sort of online decision support tool. So we go on to slide 17, kind of a little bit of a cartoon of what this kind of thing might look like, some sort of online mapping tool where you might be able to look at different types of data that we've synthesized here. If we look at the top right-hand sort of cartoon of a zoom in the region, or even better, we might be able to select specific stream reaches and maybe suggest what would happen if do sort of what if scenarios. What if we wanted this much withdrawal under these regulations? What would the ramifications be based on the data we've synthesized so far? And if we go on to slide 18, we can even think bigger than this. You could think about incorporating into a tool like this, real-time data, so that if you're in a particular year where the flows are high or low, the streams might be more or less sensitive, and you can think of this, in much bigger terms, like I say, bringing in real-time data, making this accessible on mobile devices, making it applicable to multiple different users. And so this very noisy cartoon is just to kind of suggest that there are multiple directions that this can go. And if we go to the last slide, I just kind of want to emphasize that we're sort of a small nugget in a big network of information, of resources, and both coming to us from upstream that we hope we're handing to downstream entities or resources that will actually be able to capitalize on this work. And so with that, I hope we're not too far over. We'll take any questions.
That's wonderful, Todd. Brian, I appreciate that. At this point, what I'd like to do is pass the host baton over to to Bill, and we'll go into the kind of the 3 questions that I teed up for the steering committee about the next steps in terms of communications and outreach, about the messaging of that, and Matt can brief you on that. And then, of course, that issue of the possible next steps or expansions on both the interagency agreement with ecosystem services and on the flow alterations, the environmental flows work that Brian and Todd presented. So, Bill?
Gene, thanks. Thank you, Gene. I unfortunately am going to have to sign off. I got to run to another meeting. So,
I apologize. So I'll go ahead and.
We talked about that yesterday. I'm sorry to have to just punt it back to you. Thank you.
I appreciate that. So, let me just stop for a moment before I ask Matt to talk to us about the next steps in terms of our rollout. Ask if there are any clarifying questions, Lars or Todd and Brian. Again, the purpose is not really to evaluate the research per se, but to make sure that you understand what the product is and its capacity, that you as the steering committee can evaluate how we present that to our partners and to decision makers. So are there any clarifying questions in terms of the presentation that was given? And if you would just go ahead and tell me, who's asking the question and who's directed to.
Hey, let me throw one out for consideration. I'm not sure which presenters should be answering this, but I'll ask it about both presentations. If we're putting this out there as an LCC, we're giving it sort of a stamp of approval. And I guess if I'm not technically qualified to evaluate the quality of the research, I guess the question that I would ask is, are these products we can stand behind from a peer review standpoint, or is that a set of considerations that we need to look into further?
I'll start just from the LCC perspective, and then of course pass it over to the PIs. Dan, if you'll remember, on all of our grants have a technical oversight team, which is uniquely constituted and it's based on the technical competencies of the reviewers and the technical needs of the study. So as an ongoing quarterly basis to review progress, interpretations, methodologies, interpretations, we have a team, generally 3 to 5 people. Again, they're uniquely constituted, so I can't tell you exactly who's who, but that is part of what we do as our business model for all of our research. So that's in part how the LCC is doing it for the cooperative in terms of the oversight. And I know that Brian and Lars are both in the scientific publishing part of that discussion as well. So I'll pass it back to the PIs to respond if they wish.
Yeah, this is Lars. I could just step in real briefly here. So just to tell you kind of what our general approach here is, from the very beginning, we definitely try to reach out to as many partners, collaborators, et cetera, as we can to be not sort of just reporting at the end, but also getting feedback from the very beginning in terms of, the sort of best practices in terms of our science. So we've done that with multiple groups all along in the past couple of years as we've been, well, year and a half as we've been working, and we feel like that's made the science better in some very, very material ways. And then of course we try to stay in lockstep with the LCC's process that Gene just described, and be available to deliver as much information in terms of reporting as we can for that process. And then you mentioned the peer review process as well, or sort of that as a kind of a gold standard. And of course, as researchers, we're always involved in aiming to publish the work that we're doing in peer-reviewed journals that are appropriate for the kind of science we're doing, and that's something, multiple manuscripts in process underway right now. So those will be forthcoming as the project moves forward.
And from our end, this is Brian, by the way, and then I'll let Todd add some stuff should he see the need. But essentially where we're at with the peer review process is we've already had, we submitted the paper which summarizes a lot of the findings that are in the report and adds some additional analyses. We submitted that to ecological applications, which is a pretty good journal, and it's now been reviewed multiple times by two pretty thorough reviewers. In fact, I've probably not gotten so many comments on any paper, so I think that shows that they're interested in the subject and think that there's some promise there. We've had some pretty productive, essentially conversations with these reviewers, and it's on to the final stages. The last round of edits I did consisted of two very minor, essentially copy editing issues. So that, it's not officially accepted, but it's certainly been peer reviewed, and I'm expecting to hear back pretty much any day now. So that kind of gives you an update where we're at in terms of the peer review process. I don't know if Todd, you wanted to add.
Yeah, so I think for all essential purposes, it has been officially approved. They've taken our responses to the peer reviews, and now the editor is just simply working with us sort of one-on-one for clarification. I don't think it's going out for any more peer review. And I would also emphasize Brian's comment that the reviewers really were engaged with this. They found this very interesting and gave us lots of feedback to help us clarify. Because it is, as you saw even from our presentation, it's a very complicated process to get from where we started to where we are now. And I'd also like to emphasize, and this is really a hats off to Matt and Gene and the whole AppLCC. This was a process in which we started down one pathway, and we had to sort of keep revising our approach to it as we hit roadblocks. And so we were kind of more or less constantly engaged with the LCC about how we wanted to continually change our approach to get a better and better product. And Gene and Matt were very gracious in accommodating us to let us deviate from what our original plans were to get to where we are.
Thanks. I appreciate everyone's back. Again, is there any, if you don't mind, I'll go ahead and switch over because in the interest of time, anyone that wants to stay on, let me mention two things. If we did do a roll call, if you came in late, if you could just go ahead and shoot me an email, or if you are on at the end, I can add that as well. But again, there's the two things about, or excuse me, the three things that we're talking to you about, our next steps and the outreach, and that's what I'm going to pass it over to Matt to make sure that the steering committee knows what those steps are, and that the steering committee is approving of that. Matt?
Yeah, so I'll be really quick on this. So for the ecosystem benefits and services research project, we did our public release last week. It was a joint release with the U.S. Forest Service Eastern Threats Center, Eastern Forest Environmental Threat Assessment Center out of Asheville. And we sent it out to 715 of our own contacts. The Forest Service sent it out to theirs, and we posted it to a variety of websites. All the content was jointly developed between us, the Forest Service and Fish and Wildlife Service, and really good responses, especially from organizations like the EPA, USGS, and the Northeast Climate Hub, who want to use it in the future kind of meeting they're going to in the summer. So there's been just really good response about that, about just getting the awareness out regarding the ecosystem benefits and risk research and website. And I'm doing analytics now on the website to get an assessment of how many people have visited it, and should have numbers by next week. In terms of the stream impacts research, this was we developed a communication team with Cornell and the Fish and Wildlife Service to develop key messages and talking points on this kind of sensitive, subject matter. And that's been vetted by several steering committee members, as well as people within Fish and Wildlife Service and Cornell. And we have really good, pretty much final talking points that I sent out to the steering committee yesterday. So it gives you a better idea of kind of the key messages we're framing this research around, which are kind of the stream impacts from general water withdrawals, looking at hydrofracking in particular, and those impacts to aquatic organisms. But with the overall goal of providing recommendations that balance both human energy water needs and biological water needs in this region. So along with doing the briefing to the steering committee, which we've done here, we also selected key organizations that aren't on our steering committee, state DEPs in West Virginia, Pennsylvania, New York, and organizations like the Susquehanna River Basin Commission, the Chesapeake Bay Program, the Potomac Interstate Commission, and the Delaware River Basin Commission, to kind of just do a heads up, letting them know about this research and a public outreach that we'll do later in the summer. And basically it's to get feedback, does this kind of make sense to you? Is there any messaging that is that we need to tinker a bit before we do a public outreach to a greater community, things of that sort. And so obviously, I'm sure most people on this call are looking at these messages for the first time, and so if there is any input you have, I mean, certainly you can say it on this call, but also feel free to email me in the weeks ahead. Obviously, the communication team, which is composed of AppLCC, Cornell, Fish and Wildlife Service, will be incorporating edits and comments into further outreach products that we do from this research as we prepare for a more public general release like we did research. Jean, that's kind of my spiel for now.
Thank you, Matt. I know that we are about to hit our hour and the 11, and so I wanted to do a couple things because of the fact we have lost some of our discussion time. Those questions and the things that Matt just mentioned, we will follow up with everyone. Again, if you came in late and or not on the roll call, please send me an email so we include you on that. We will send out a email that asks for your feedback in terms of the communication, the strategy, the messaging, and then I will ask you in that email to also weigh in on your impression of the research in terms of how the researchers have framed possible next steps. And so generally how that's handled is if the full steering committee thinks a research interest is warranted, then you have been previously handing that over to the executive committee to follow up with nuts and bolts and clarification. So I will be asking whether or not you think it's appropriate to investigate that, and if you are comfortable with allowing the executives to do that on your behalf. So just in one more thing, in your email you have two things that are brought up. Number one is to ask you about going on and reserving your rooms for the July meeting, but also July 1st, Paul Leonard will be giving a briefing to the full steering committee, again, to talk about the modeling, and that's part of the preparation for the July in-person meeting. So again, if you to look at that email from Matt, it actually has those three contents. So because of the lateness of the hour, I'm just going to ask, are there any questions? If anyone is able to stay on, we're happy to continue the dialogue while we have the researchers. Do you have any questions? And if not, then I'm going to ask anyone that came in late after the roll call, if you can just announce yourself. That might save us sending an email.
Hi, Gene. This is Scott Schwank with North Atlantic LCC.
Hey, Scott. Thanks so much.
This is John Ambrose with Georgia DNR.
Oh, John, thanks so much.
Hey.
Okay. Well, I hope the others are able to do that. So again, I appreciate everyone's time and tolerance of our technology that we're living with, but I appreciate everyone's time and input, and we'll continue that dialogue through our email exchange. Thank you, Todd, Brian.
Thank you, Gene.
Lars,
Thank you.
Appreciate everything, and thanks, Jessica, for
Have a good weekend
as well.
Yep. Happy Friday.
Bye-bye.
Bye-bye.
Bye, all.
Bye.